Hello everyone, welcome to our YouTube channel BSS Setu. I hope you all are doing well. My name is Salina Khan and today I'll discuss the most important topic of Organic Chemistry Class 11th with you. The lecture will be divided into two videos. The first is dedicated to understand the steps of writing the IUPAC name, and in the second video, we will be implementing what we learned in the first video using examples. Let us discuss the learning outcomes of the lesson first. In this lesson, we will be able to name the compounds according to IUPAC system of nomenclature. We will be able to derive the structure of compounds by the given name. We will be able to state the name of the compound by its structure, and we will be able to state the scientific name of common compounds we use in daily life. Let us start the lesson with some questions. Students, what are organic compounds? Yes, organic compounds are carbon-containing compounds in which one or more atoms of carbon are covalently linked to atoms of other elements, most commonly hydrogen, oxygen, or nitrogen. Students, are you aware of the compound cinnamaldehyde? Yes, it is a natural food additive that comes from cinnamon. Is cinnamaldehyde an organic compound? Absolutely, it is an aldehyde and thus an organic compound. But do you know what is the IUPAC name of cinnamaldehyde? You don't know the answer? No problem, because in this lesson we will be learning about IUPAC nomenclature through which we can give the standard name to our organic compounds which are universally used and recognized. Well, IUPAC is the International Union of Pure and Applied Chemistry. It is an international federation of national adhering organization that represents chemists in individual countries. It is responsible for naming the organic compounds according to some rule. As I said earlier, cinnamaldehyde is a lovely name for a lovely aldehyde that is extracted from cinnamon. But there are tens of thousands of regularly used organic compounds, and we cannot come up with pretty names for all of them. Most important than that, we cannot translate those names into chemical formulas, and thus IUPAC created some rules for naming the compound. According to these rules, IUPAC named cinnamaldehyde trans-3-phenyl-prop-2-enyl. This name is better because if I say trans-3-phenyl-prop-2-enyl to somebody properly educated, they can just write down its chemical formula, which look like this. IUPAC created a language that could be understood by anyone with minimal, even zero misinterpretation. Let us go through the steps of naming a chemical. It is a multi-step process. Step 1. Number of carbon atoms. If there is one carbon atom in the compound, it is called meth. If there are two carbon atoms, then it is called eth. 3. Prop. 4. But. 5. Pent. 6. Hex. 7. Hept. 8. Oct. 9. Non. 10. Dec. In the first compound, there are 5 carbon atoms and thus it is pent. In the second one, there are 7 carbon atoms and therefore sept. In the third one, there are 3 carbon atoms, thus prop. And in the last one, there is only 1 carbon atom and we call that meth. The second step will be the longest carbon chain. Here, we start naming the carbon atoms in the chain so as to obtain the longest carbon chain possible. Sometimes, a hexane can look like a pentane with an ethane sticking off it. In this image, you can clearly see 6 carbon atom chain. But it can look like a 5 carbon chain compound also when you look in the different direction. So we usually take the longest chain. Now that you know your longest carbon chain, you've got your prefix. Time to find out the suffix. If there's nothing but hydrogen and carbon, your suffix just depends on whether you have any double or triple bond. So, the third step will be number of bonds. If we have a single bond, we say "ane". For a double bond, we say "ene", and for a triple bond, we say "ine". So, propane, propene, and propyne. Then there are tons of other groups that can change the suffix, like functional groups, alcohol, aldehyde, ketones, etc. So the next step will be to find the functional group. When working with functional groups, each one adds a particular suffix to the end of the name of a compound. Usually, these are pretty easy to understand and remember because they come straight off the name of the functional group. Let us see how. Alcohols add an OL. So, for methane, we drop an E and we add OL. It becomes methanol. Ethane becomes ethanol. For aldehyde, replace the E with Al. So ethane becomes ethanol. For ketone, add one. O-N-E, one. Hexane becomes hexanone. For amines, straight away add amine, like methanamine and propanamine. For carboxylic acid, add oic and acid to the name, so it becomes ethanoic acid. Repeating all again, alcohol, replace E with OL, ethanol. Aldehyde, replace E with Al, ethanol. Ketone, replace E with ONE, ethanone. Amine, replace E with amine, ethanamine. Carboxylic acids, replace E with oic and add acid, ethanoic acid. Other than these, there are chlorine, bromine, fluorine and iodine that when present in a compound give its suffix chloro, bromo, fluoro and iro. The step 5 is parent functional group. Now, it is perfectly possible that a molecule will have two different functional groups. Then how do we know which one is the parent? Which one defines the suffix? Well, different groups have different precedence. The most weighed of all is the carboxylic acid functional group. No matter what else is on the 6th carbon chain, if there's a carboxylic acid, then it is a carboxylic acid. See for yourself. In this compound, there is a carboxylic acid. So it is hexanoic acid. In the next one, there is an OH group too with the carboxylic acid. But due to the precedence, we say hexanoic acid only. In the third compound, there is double bond and there is a carboxylic acid too. We still call it hexanoic acid. The precedence is decided by a list that was created by IUPAC to minimize confusion. Okay, so now that we have created our base name for the molecule, it's time to start looking at what else is attached to it. Any side chain or functional group sticking off the side have to be identified and named. In the next step, we identify the hydroxyl group, where it is, and identify if there is a double bond or not. And the last step, will be to find cis or trans. Cis prefix is given when the functional groups are on the same side of the carbon chain, while trans convey that functional group are on the opposite side. And these were all the steps to name an organic compound. So in this lesson, we studied about IUPAC. It is the international organization that creates a system where every organic compound has one and only one name to prevent confusion. They do this by giving prefixes to compounds for the number of carbon in a chain, suffixes based on parent functional groups, and ranking functional groups somewhat arbitrary for precedence. We also learned that we have to number our carbon chains so that our parent functional group has the lowest possible number. We also learned about cis and trans. I hope you all enjoyed this session. In the next video, we shall take up examples to better understand the steps of naming the compound. Till then, stay safe and keep learning.